I'm Alessandro Levi, electrical engineer and partner at Prime Movers Lab, and I will be moderating today's discussion on semiconductor, global chip shortage, and future trends, together with my fellow PML partner, David Siminos. I'd like to start by welcoming our audience. I see many of our limited partners, founders, and extended Prime Movers Lab family. I'd like also to extend a special welcome to our new Growth Fund LPs. We are grateful to all of you for being on this journey with us. For those new to Prime Movers Lab, we are a deep tech venture firm investing in prime movers, the entrepreneurs that have the ability to positively impact billions of lives. We focus on breakthrough science companies in 6 broad industry verticals: transportation, energy, agriculture, human augmentation, manufacturing, and infrastructure. Given this, we live on the front lines of our tech innovation. We have seen over 2,200 companies so far this year. Every 2 weeks, we host webinars to share what we are learning, to spotlight growing industries, and highlight the amazing people that are speeding up this massive adoption of technology that we are starting to currently use or we will use in the future. I'll put in a plug for our next webinar in 3 weeks, September 22nd, same time, on the future of data storage, DNA and biological solution, hosted by partner Caleb Bell. So before we begin on today's topic, let's do some quick housekeeping. We want to be mindful of everyone's time. We will keep this to 1 hour. David and I will lead the discussion for about 30 minutes, and then we will open it up to all of you for questions. We absolutely love to hear from you. Please use the chat and the Q&A feature to submit them. We will save time to discuss with all of you. With that, I'm thrilled to be hosting this webinar with my partner, David Sivinov. Please, David, introduce yourself.
Thank you, Alessandro. So I'm Dave Simonoff. I'm a general partner in the Growth Fund. I manage it with Zia Huck, who I know a lot of you have met. My background is deep in the weeds of Silicon Valley. My dad moved there in the 1950s after being part of the Army-Navy radar joint venture program, where he pioneered a whole bunch of wireless technologies. When he moved to the Valley, there were a whole lot of transistors and not a whole lot of semiconductors. And basically, I watched the industry almost literally grow up around me. So my dinner table was filled with Dad arguing with legends of the business, from Andy Grove to Bill Hewlett and Dave Packard and the whole gang who kind of really built the Valley. So I was deep in the stack. You know, if you grew up in Beijing, you probably speak Chinese pretty well. So I grew up in Silicon Valley, so I speak fluent semiconductor, and I come at it from very much a utilitarian perspective, in that the chips are great, but it's all about what you do with them that makes them interesting and give value to the world and change the conversation. So that's kind of my focus here. I have a bunch of crazy hobbies where I push the edges of semiconductors today. I'm on the astrophysics board at Princeton, and I have a ginormous telescope in my backyard here in Wyoming, where I make the chips burn because they're thinking so hard. So with that, Alessandro, back over to you.
Yes, so just a quick intro of today's topic. Prior to COVID, the average person did not talk about the global chip shortage, semiconductors, and supply chain. Fast forward 18 months, it's top of mind of everyone because it's having a real world impact. For example, recently my little cousin wanted to buy a gaming console, but there were no quantity available. A couple of months ago, I called a technician to repair a dishwasher, and he mentioned 16 months to get the required chip to fix it. I wanted to buy a new car, but the backlog is more than 12 months. Some companies are not feeling the impact as much as others. For example, Apple is on top of the list of components manufacturers. If they stockpile chips while continuing to order more, this creates a greater gap in the industry, and it's impacting both large and emerging companies. What about our portfolio companies, David?
Sorry. You know, the chip shortage here has been, I think, a shock in many levels. Even though a lot of us knew it was coming, we knew that there would be friction in the system. The level of friction has become this geometrically compounding problem. And what I mean by that is that from our perspective, dealing with companies like Toronto Wireless, which is one that relies heavily on the global chip supply chain and a whole bunch of other things contiguous with it, the big dogs in the field, Apple, Ford, even Nike, believe it or not, have priority in ordering chips. And of course, in any kind of panic, because they're powerful, they exercise it. So they've ordered 2, 3, 4, 5 times as many chips as they need, knowing that the orders are cancelable within a very short notice. And so they take on their very large balance sheets the risk of owning the inventory of all these chips and other supply element pieces. So what you've seen is a backlog that looks like it's 14 decades long, when in fact what will likely happen as the supply meets the demand, and we hope that happens sooner than later, a lot of these backlog orders will get canceled and things will normalize and equalize. And oh, by the way, this is not the first time in history this has happened. Many other confluences of world events have changed supply chains. I remember the OPEC oil embargo of the US changing the throughput of plastics and all the first derivatives of oil elements. So backlogs at the worst time of that in the late 1970s were 3, 4, 5 years to get, PVC pipe. And then all of a sudden, Reagan came into office, everything changed, the embargo ended, and like 6 months later, everything flowed cleanly, and then prices really bottomed because people just had oversupplied themselves and nobody was ordering anything. So I'm hoping we have a less violent reconnection of supply and demand here on the econ graph soon.
All right. So let's ask our panelists to introduce themselves. Professor Shi.
Hi, Alessandro. My name is Willie Shi. I'm a professor of management practice at Harvard Business School. I worked in industry for 28 years at companies like IBM Digital Equipment, Silicon Graphics, Eastman Kodak. During those times, I did a lot of chip work, mostly on the RISC microprocessor side. I was one of the people who did the PowerPC deal back in the early 90s between IBM, Apple, and Motorola. Okay, and then I've been at Harvard Business School for 15 years now, done a lot of studies on especially Asian semiconductor manufacturers like TSMC, SMIC, and others.
Andre, you are one of our great portfolio companies. Please introduce yourself.
Thank you, Alessandro. Good afternoon, everyone. My name is Andre Yanku, and I'm the founder and CEO of Halo Industries. At Halo, we create unique laser-based hardware systems for advanced materials and device fabrication that drastically reduce waste, improve quality, and enable next-generation products such as flexible electronics, displays, and so on. Our technology is broadly applicable, especially in the semiconductor industry, but also across a wide range of fields. The company, however, is rapidly scaling towards volume production to bring its first solution to market in the power electronics space, with a focus on electric vehicles, associated charging infrastructure, and similar high-tech electrification applications. I've been an engineer for the majority of my career, having earned BS degrees in electrical engineering and aerospace engineering at Iowa State University, then subsequently MS and PhD degrees at Stanford in aeronautics, astronautics, electrical engineering, and mechanical engineering. And Halo Industries is actually a spin-out from Stanford, leveraging novel technology we originally developed there at the university. And I'm very grateful for the opportunity to join PML and the other esteemed panelists here for this discussion on a very fascinating topic I love and spend a lot of my time on, both at work and personally. So thank you.
Wonderful. Then your turn. You have a lot of experience in both in the semiconductor industry, consortium, and also an accelerator. Tell us more. Introduce yourself.
Yeah, hello. Thanks for the invite. I grew up in IBM, and that was in manufacturing and ran the 200 millimeter and 300 millimeter fabs. I'm sure I probably didn't deliver Willie's chips on time, but I'm sure they were high quality. From that, I ran the semiconductor consortium called Semitech. It did collaborative, pre-competitive R&D for all the industry. While I was there, we really focused on EUV lithography, which is now broken through into the latest generation of manufacturing. And more recently, I co-founded an accelerator that focuses exclusively on semiconductor early stage startups. And our goal is to get prototyping done for free. And it's grown quite a bit. And we've incubated about 50 companies. And it's a long incubation, it's 2+ years. It's unique to the requirements of the industry. I work with the national labs, looking around the corner, what comes after CMOS, because we know it's not going to continue forever. And in that context, I got to meet Andre, and I've been working side by side with him as he scales up, getting ready for volume production. So pleased to be here.
Wonderful. Great. So let's start with some background information on chips. Dan, this question is for you. For those who don't know that, can you tell us what is a semiconductor chip, its purpose, and is there just one type, or there is a variety of chips?
So it's the brains behind every device we operate and communicate with. Simply, a semiconductor chip is a thin piece of silicon made from a round semiconductor wafer. Typically, it's 12 inches in diameter. The wafers go up through 800 processing steps. It can take 2 to 4 months. And we're making the transistors and wiring them up. And after that, the wafers are sliced into several hundred or more individual rectangles, and that's referred to as a semiconductor chip. And each individual chip can contain up to 50 billion transistors. That's 50 billion transistors, and does exactly what the chip designer wants it to do. So what types are there? They're just one. There's several types. Simply logic for calculations, memory for storing information as bits of ones and zeros, and analog and MEMS, or micromechanical systems, for interacting with the real world. So over 95% of these logic, memory, or analog circuits are made from single crystal silicon as a starting material. And they use the same equipment and the same materials regardless of the circuit type. Although more demanding applications such as high voltage, high frequency, high power are made with different starting materials, such as silicon germanium, gallium nitride, and silicon carbide. And the latter's the business that Andre is first to ramp up.
Wonderful. That's great. So I guess the chip for my dishwasher, it's much easier to make than a chip that goes on a phone.
Yeah, typically we measure the complexity by the size of the smallest component. And so you hear it referred to as a node. So it progresses downward in dimensions and roughly is the size of a transistor gate, but not actually. So you hear things like 45 nanometer, 28 nanometer. Well, we're all the way down to the manufacturing technology of choice for an Apple phone is 5 nanometer. Well, many automotive parts and dishwashers are probably still back at 130 nanometer, 90 nanometer, 60 nanometer. And there's a good roadmap over the next 10 years. We'll get all the way down to 1 nanometer, and then we got to switch to something new. So yeah, they go from just maybe 100 steps and a couple levels of wiring to we've got stacks now of 14 levels of wiring and way more steps, 8x more steps. So the complexity will vary based on what you're trying to implement.
Okay, that's great. So Professor Shi, when the pandemic hit, we started noticing that it was really hard to buy new laptops, game consoles, routers, even cars. The common denominator, it seems that it was a lack of supply for chips. What really happened? And what was the main cause? Tell us more and let's have a discussion on this topic.
Well, okay, now we tend to talk of the chip shortage as, one thing that uniformly affected everybody. In reality, as Dan has points out, there's many different parts of the chip sector. Okay, now obviously when the pandemic hit, there was a big boom in work from home devices, sales of notebook computers, flat panel screens, but also things like game consoles and things like that. So first of all, demand went up. Okay, now one of the highest profile shortages has been in automotive. Okay, and obviously, when you are a typical car these days has probably more than 100 controller chips in it for things like, the infotainment system, the power windows, okay, the so-called hospitality features of a car, power windows, lights, engine controllers are a very important part. You couldn't make a vehicle these days without an engine controller, along with all those sensors Dan talked about, MEMS devices and so on, because that's how you meet the emission regulations in fuel economy, is through very precise engine control. So all of that stuff is very important. Now, I think it's important to have some perspective on what happened in the auto market, right? Because most people miss this. And first of all, the first thing to understand is the world's largest auto manufacturing market is actually China, right? Which has typically been as many as 28 million, 29 million vehicles back in 2016, and then in 2018 and 19, going into 2020, it was down a little bit. The US is typically, we manufacture 11 to 12 million vehicles, and we sell 17 million. So we import a lot of vehicles. Okay, but China is the largest market. And the reason that's important is going into January 2020, before the pandemic, the China market forecast was already down, right? Because 2019 was a down year compared to 2018 and down compared to 17. So it was a down forecast for the China market, the world's largest. Okay, then what happened, of course, is the pandemic hit. And in February 2020, vehicle sales in China went down 82%. Now, China recovered in March. It was only down 46%, but then, they were a little ahead of the rest of the world. Sales in Europe in March of 2020 fell 46%, and in April, they fell 80%. Okay, now the US was a little further behind the curve. In March, they fell 39%. In April, they fell 52%. Okay, and people forget, in April 2020, the US automakers were worried about, they didn't want to go bankrupt again, right? So what did they do? They said, stop all those incoming orders, right? I don't need that material. I don't want to pay for it. All right, so, and in fact, there was a famous BCG report in May of 2020 that says, in kind of the most optimistic scenario, global auto sales would be down maybe 12% for the whole year, right? So everybody was cutting their forecasts. Okay, now, meanwhile, work from home was booming, right? And what a lot of people don't realize is, if I'm using some of these more mature chips, like for engine controllers or infotainment stuff, or power windows, those are going to be very old technology. Those go to a common supplier base. It may be the same ones who are making timer controller chips for your washing machines, or for, your flat panel display. Flat panel display drivers have been were in shortage early on because there was a lot of demand. Okay, so by the time the automakers realized things were not going to be so bad in the summer, and they come back and say, we want to reorder those chips, that capacity had been soaked up by other players. Okay, so it's like, oh, surprise. Now, the other thing that happened, right? People tend to think it was like, well, just one thing. We had a fire at a Japanese fab in October. It was AKM, the Japanese fab, and they were specialized like in audio chips, analog to digital converters, and things like that. We had that winter weather in Texas that caused the Samsung fab and the NXP fabs in Austin, Texas to shut down. And when you shut down a fab, restarting one is going to take you a good 60 days or so. Okay, and then we had another fire at a Renesas fab in Japan in March of this year. Okay, and Renesas is a large supplier for microcontrollers for automotive engine controllers, as well as for appliances and things like that. So we've had a series of all these things. Okay, so there are different types of chips. Companies like Apple, mostly what they consume are the high-end chips, right? As Dan was mentioning, 5 nanometer in their current generation, iPhones and stuff like that, right? So that's a different category. And Apple being a large customer of these fabs, they get premium treatment, but that capacity has all been committed to. Another thing that happened in the midst of this, and a lot of people forget about that, is the US was threatening to put SMIC on the entity list. SMIC is a large manufacturer of kind of the more mature technology chips, 28, 65, 45 nanometer, things like that, right? And so a lot of those people who sourced from SMIC rushed to Taiwan. Also in 2020, the US sanctioned Huawei, right? And so there was a big threat of cutting off supply to Chinese companies. So in the summer of 2020, these guys just loaded the Taiwan foundries up with orders because they wanted to stockpile chips. Okay, so all these shortages kind of piled up. And then, as you see shortages, everybody says, I think I want to have more safety stock. Okay, I'm not sure if it was 5X ordering. Nobody will admit to multiple orders, but the way you have to think about this problem, I was talking to one notebook computer maker. It's like, no, demand is holding up really well, I'm sure. Okay. And if you have chips because you've stockpiled them, you can gain share over your competitor who doesn't have chips. Okay. So everybody is incented to have just a little bit of extra, right? So you take all of these things together, and we really have a lot of shortages everywhere. And then, of course, most recently, what most people don't realize is even if the chips are produced in the big foundries in Taiwan, which is more than 50% of global capacity, after they're produced, then they have to go to either China or Southeast Asia for packaging. Okay, and what's happened in the last couple of weeks, of course, is that we've had these severe COVID outbreaks in Malaysia in particular, and Vietnam. Okay, now it's starting to affect Thailand as well, but that's affecting chip packaging. So if you don't get it on the front end, you get it on the back end. So it's not any one thing, it's a string of a lot of things.
And to add to that, let's say it's a clear signal I need to increase capacity. It's lead times for equipment. By the time I order, it gets delivered, I install it and qualify it, at best 9 months, probably right now, 18 months. And then it's going to take 4 months to build the chips with that new capacity. And then ultimately it's going to be incorporated into a system, and all the chips have to arrive in that system on time and be assembled. And so it's when we're out of equilibrium, things go exponentially haywire.
And one of the ways to think about it, if you're an electronics assembler, okay, and I'm on the board of one who manufactures a lot of products for people, you talk about, is my product clear to build? As Dan says, let's say you have a smartphone, right, which has 4,000 parts in it, right? If I'm missing one part or short one part, it's not clear to build. I can't build it, right? So it's not like necessarily a high profile chip. If you look at the chips that are short, a lot of them are just commodity power management, okay, timer controller, simple things like that. And, so it's a mess.
Can we say that a company product is as stronger as the weakest components in that is inside the product? So the weakest one single chip can block the production.
Well, and I'm going to be a little critical of U.S. automakers here, who have been very transactional with their suppliers. Okay, they historically have had punitive arrangements with their suppliers where, if you don't supply on time, you pay very heavy penalties. Okay, but I don't want a lot of inventory. I'm going to have lean production, blah, 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 blah. Okay. And now they're paying the price for that. If you look at Toyota, who until recently has not suffered as much. Okay. It was because, we had a previous shortage back in 2011, March 2011, the Tohoku, East Japan earthquake and tsunami, which took out the Renesas fab, which again, 10 years later had that fire this past March. And Toyota learned their lesson. It's like, we don't want to be so lean on our inventories on that stuff, right? Because for lack of a $5 chip, to be unable to produce a $50,000 retail MSRP vehicle is crazy, right? So they were much more strategic about it. Now they've gotten in trouble lately because of the outbreaks in Southeast Asia, because they are dependent on there for a lot of other components. They have not been particular about what they're short, but now the Southeast Asian shortages have hit them. But it's how you treat your suppliers, and how you think about this problem is also very important.
So on this topic, what can companies do to improve? You mentioned that the relationship with suppliers is very important. The just-in-time model probably must be revisited. So which step can companies do to prevent
let's talk about just-in-time. Okay, now
yes.
Just-in-time and lean production came from Toyota, right? And that was because, and we don't need to go into that story. I think everybody understands that one. Okay, but if you look at Toyota historically, to them, lean production was predicated on having a supplier network that was surrounded them. You go to Toyota City, you go to some of the factories around Nagoya, suppliers are all within an hour or 2 hours, not far away, and they partner with suppliers to give them visibility. Okay, even if you go to Toyota in Georgetown, Kentucky, they have a very high number of suppliers in the state of Kentucky or southern Ohio or southeastern Indiana. Okay, now a lot of manufacturers have taken that lean concept and extended it globally. And if it's chips, most of those move by air, but a lot of products move by ocean. And so they've taken as a given that I have reliable, low-cost logistics. And of course, in the pandemic, that has turned out to be a bad assumption. So, a lot of it takes a more thoughtful approach. Obviously you can invest a little more in safety stock inventory. You can have more flexibility in being able to substitute alternate parts. That's what Tesla has been doing. They've been quickly redesigning to substitute different parts, right? Most automakers require a extensive qualification process before I will allow you to use these alternate parts. I'm not sure what the deal with Tesla is that allows them to substitute so quickly, right? Or you can carry more inventory for safety stock. People don't like that because it costs money and you have risk of obsolescence. My prediction is, I went to one of these events where one of the big automakers was talking about their new partnership with their semiconductor foundry supplier. Okay, and my prediction is in about 3 years, the CFO of those companies is going to come back and say, how come we get so much inventory? Why don't you generate some cash by getting rid of some of this inventory, right? And then, then we'll be back to where we started.
Well, we saw this movie in the internet build up around 2000. Also with Y2K, there was a similar sort of multiple ordering, supply chain imbalance. Everyone was trying to get in line at the fabs. And then she collapsed, and we were able to look retrospectively and realize that there was a lot of double ordering and cannibalism, trying to take market share. So, fabs and foundries aren't dumb. They saw that. And so this time around, everyone is talking about take or pay, or in other words, a capacity reservation. that is guaranteed to you. So I think we're going to get more rationalization and redistribution of the risk in the supply chain to a more balanced position. We've seen the movie, people have learned from it, and there'll be adjustments.
Yeah, I agree with that. I was talking to some people at TSMC some number of years ago, and just as it was a funny example, this was more than a decade ago, but remember the old days when you made a PC and there were Northbridge and Southbridge chips? You guys remember that, or am I dating myself? Okay, but so TSMC, and there were three major suppliers of Northbridge and Southbridge chips, right? And TSMC made the chips for all of them, right? And they knew what the forecast for the total number of PCs was, right? And so then they would look at the forecast for Northbridge and Southbridge chips, and they told me it's like every one of these guys thinks they're going to get 100% market share, right? That's not going to happen, right? But that's just kind of the behavior that sometimes they see. So the answer is you as a foundry, you have to put discipline on these guys. And as Dan says, take or pay is a new thing. It's like you want chips now, you're going to pay for capacity up front, whether you use it or not.
Very interesting. You guys mentioned there is a geography where the biggest foundry in the world are located. And this could be also, could be a problem if something happened in that specific geography, in that specific part of the world. Could be a war, could be a earthquake or a tsunami. So Andre, you work a lot with different foundries. So which are the biggest foundry in the world and where they are located geographically?
I mean, TSMC is obviously the big dog, as I think Willie also pointed out, over in Taiwan. It is a bit difficult to top them nowadays. I know there are some contenders in Samsung and Intel out there. But I think what you see now, and kind of layer on top of some of the comments from Dan and Willie, is we're also seeing something similar happening in the equipment market. So now, for example, when we go to order, say, a polishing system or a grinding system or a thermal treatment system, lead times have gone from something like 3, 4, 5 months now to 12 months, 14 months. And I think what you're seeing is that in the equipment market, people are placing orders, so you can reserve a slot, a production slot, but then maybe not necessarily using them. So you're seeing this additional effect as folks try to ramp up capacity, but they're kind of hedging their bets and placing orders, potentially knowing that they just have to spend a little bit upfront for the option to buy a piece of equipment. But that obviously exacerbates all the issues that we're seeing in the industry because the lead times are just getting obscene. But big players like TSMC or Samsung or Intel do have priority. So a lot of the other folks are certainly struggling to catch up and adapt to the new environment. So it's a much different game that the different players play depending on where you are in the stratification.
And also we know that equipment is it's a very important part of this technology war. I heard that the Trump administration, for example, they prevented the biggest lithography producer, ASML, to sell their equipment to SMIC. So tell us more how the equipment is key to guarantee a technology advancement for a country.
Oh, absolutely. Speaking specifically to ASML, the ASML equipment literally enables the highest technology nodes that Dan mentioned. Those 7 5-nanometer nodes down to 1 nanometer. ASML technology is really the only thing that can enable those types of devices. So by shutting China out of that equipment, they have to replicate that technology, which is incredibly difficult. So it effectively delays their progress. It is very strategic, although a very aggressive move on behalf of the US here to try to maintain its competitive advantage.
Although I should add that is not new with just the Trump administration. If you go back through the history of SMIC, they have, as long as I have known them, complained about how hard it is to get export licenses for some of that equipment. One of the consequences of that is they historically have always been several nodes behind.
Mm-hmm. And that's very strategic on the part of the US. And you can argue as to whether that's right or not, but it is one lever that the U.S. controls pretty tightly through large companies such as Applied Materials, Lam, KLA-Tencor, and ASML. Although ASML is technically a European company, the U.S. they have a lot of production facilities here.
Well, that's because a lot of the key components come from the U.S.
Right.
Or technology has its roots in the U.S.
The laser source in particular comes from Cymer San Diego as a subsidiary. But to add color, why lithography comes up so often, there's equipment and then there's lithography. Equipment costs between $1 and $10 million a piece. Lithography, the latest EUV system, $150 million. It weighs 40 tons. It takes several jumbo jets just to transport the components. It's a huge deal. To say that if you choke on EUV, you can't import them, I think conservatively, best case, it would take 10 to 15 years to build an equivalent capability if you could pull it off. And there's just the physics prevents you from using older generation lithography to make the smallest dimensions. So we truly in the world are bottlenecked with a monopoly on EUV. Nikon and Canon were competitors in prior generations. They couldn't afford the immense R&D. In fact, it took Intel, TSMC, and Samsung to put in cash to keep ASML on track before EUV finally made it. We started EUV in 1990 with DARPA funding in the US, and it took 30 some years to get it into production, and a lot of collaborative work across the world. And so moving forward, one of my fears is if we start taking up nationalistic borders and thinking that way, a lot of what the semiconductor industry has benefited from is global cooperation. And if we start fracturing that up and rationalizing it differently, it would be very hard to construct a supply chain if you start dividing the world up into too many pieces.
And from my perspective, it seems like it's already starting to divide. Looking at investments in particular, Chinese VCs are effectively excluded from semiconductor investments in the US, as far as I can tell, based on my contacts through the ecosystem. So it seems like we're starting to build two separate verticals, one in China and one in the rest of the world, for manufacturing these devices. I'm not sure, Willie,
I think part of the problem there is that, especially in Washington, the level of understanding of this technology is relatively sparse, and understanding of supply chains and interdependencies is very sparse as well. So, the current administration produced their 100-day report on these critical supply chain dependencies. They sent it to me the morning it came out, and I read the whole report, 220 or whatever pages. I read the whole thing, and one of my reactions is like, when you are done securing these 4 critical commodities, I will give you 4 more that we are dependent on the rest of the world for. And when you're done with those 4, I'll give you 4 more. Okay, and when you're done with those 4, I'll give you 4 more. And how long would you like to play this game, right? People don't realize how much we, not just the rest of the world, how much we in the US benefit from the whole world, access to, the brightest minds around the world in so many areas, right? People have no appreciation of that.
Can I jump in with a question for guys, any of you? And we had this from Andrew McKee in the audience, which I think frames things very well. The global interdependency on technology in the ecosystem here, and I would argue the New World Order is a technocracy as much as a democracy or tyranny or whatever country you're from. What happens if China becomes much more aggressive in controlling Taiwan? And then you can imagine the notion that they would want to control TSMC the way they do there are other companies inside of China. What happens to the world system? Because you can imagine a very grim scenario where TSMC only feathers out, product to people friendly to China. That becomes a political negotiating chit. How do you guys think about that in the global ecosystem here? Because it's going to play into a lot of things, certainly that we invest in, that we do. And thank you, Andrew, for the question.
David, good example, and it's just one example of a chokehold. But even before that, if China decides it doesn't want to ship precious metal, it could shut off virtually every high-tech industry, because we simply aren't even close to beginning to mining the precious metals outside of China that would be necessary to keep all industry going. So there's a lot of reciprocity here. There's mutual dependence. We have to be very careful about thinking that we are asymmetrically advantaged if we just get tougher. The world's more complicated than that, and the ramifications of the pandemic just showed us how, in many ways, and that might be a starter set for something we have to be very careful about, between logistics, raw sourcing, and let alone the intellectual property. There's Willie spent his life, maybe I should learn from the master.
Well, I don't know. I mean, if you put yourself in China's shoes, one of the problems is that we have been weaponizing exports and, economics for a long time. Okay. One of the things that really freaked them out was after what happened with Ukraine and the Russian invasion of the eastern part of Ukraine, and how the US applied sanctions to the SWIFT system. Okay, that's when they said, wow, these guys are, have economic power and willing to wield it. All right, now I happen to be in Shanghai when this is probably around 2017, I don't remember exactly when we sanctioned ZTE, which is a competitor of Huawei. Now in Shanghai, ZTE had 70,000 employees, well-paid engineers, right? I mean, they're a major telecom company. Everybody on the street was asking me, is the US going to put ZTE out of business? Okay, so a lot of what you see in China in terms of the Made in China 2025 policy, and I'm surprised people haven't picked up on this, Xi Jinping's dual circulation strategy, which is, we want the world to be dependent on us, but we don't want to be dependent on anybody else. By the way, just from a global trade perspective, as far as I'm concerned, that doesn't work, right? Trade has to be mutual. It has to be two-way. Okay. But, there is a point of view, you could say, that the US pushing China the way we have, and other countries using, sanctions and economic tools, has led to that. Now people are, frankly, people in, the US government that I talk to are very concerned about what might China do to Taiwan. When I talk to my friends in Taiwan, they say, well, these fabs are way too valuable. If China invades, they're not going to touch them because they're way too valuable. Okay, although that's not the real issue, right? It's really control, and might China then be able to do to the US what the US has done to others? Okay, now to Dan's point, I talked to my friends in DOD, the big joke is, what should I do with this manganese stockpile in the backyard, right? Because I've been telling them, it's like, you ought to see what the supply chain for manganese looks like, right? A lot of it comes out of places like South Africa, goes to China for refining. Okay, and you say, why do I care about manganese, right? It's like, because you can't make steel without manganese. All right, manganese is a crucial component of steel, right? But, so much of the refining capacity for manganese is in China, right? So, we need to be very careful before we engage in that kind of economic warfare, because we don't know where all our vulnerabilities are.
Great. And question
Not
on,
to be too, I don't want to be too much of a downer here, okay? But it's like, we need to do a better job understanding these things.
and for example, if we put ourselves in the shoes of companies, often they look at their tier 1 or tier 2 suppliers. Should they spend more time and money to go deeper into supply chain? And are there any tools to map out their supply chain and vulnerabilities?
So I would say yes, of course, but that is an expensive and complex process, right? And all you have to do is think about kind of the tiered structure. Like if I take, a notebook computer that might have 300-400 suppliers, okay, and each one of those suppliers has dozens of suppliers, and each one of those suppliers has dozens of suppliers, right? How far down do I want to go, right? That's an expensive process. And by the way, many of your suppliers don't necessarily want to disclose who their suppliers are because they're worried you're going to disintermediate them. So unless you are somebody like Apple, who has the resources and the purchasing power to mandate that type of analysis, very few people know beyond their second tier. And it's very hard work to do that.
And to add to that, many of the supply chain has rationalized down to 2 or 3 suppliers. You could go deeper, but they're just not economically viable to recover the capacity that you've lost. And so they can be shallow in many points.
Or sometimes you're surprised because as you go down 3 or 4 tiers, you end up at the same place, right? Because maybe I bought a chip from Texas Instruments, or maybe I bought one from NXP, okay? And those are both fab-like companies. They have their own fabs, but they also outsource to UMC or TSMC or somebody like that. And it's like, oh, we connect at the same point.
And for example, when companies go, rely on a single supplier for a components, usually they can get access to the best component supplier for their product. If they start, relying on multiple suppliers, is there any potential issue for these companies?
Well, just to break that down into practical terms, in Willie's day, it wasn't that unusual that you would have a dual source strategy. You would take a design out with a little bit of effort, but you would, to multiple suppliers. As we've gotten down into the nodes, the differences are such that it's awful hard to take the same part and recustomize it to accommodate Samsung. If you were foundering from TSMC, you might predominantly use Synopsys design tools. You could, in time, convert your design flow to Cadence or Mentor, maybe, but the switching costs would be tremendous. And so it's not only a desire to maybe have a more robust supply chain, there's a very practical set of consequences of building redundancies and maintaining them, and it's getting harder and harder as the very best of capabilities are way better than the next set of alternatives. So there appears to be choices when you look at it with, at a high level, but if I was running one of those organizations, it would be you would have to make a very limited amount of bets as to where you thought the supply chain might break and how you wanted to manage that. But good luck forecasting where exactly it's going to break.
Okay.
Guys, can I add just a little bit of a different question? We've seen Moore's law in existence for an astonishingly long time. We have revolutionary technologies that are promising on the margin. Can you give us a perspective of the future of sort of processing power and duration and all that? And I kind of say this in the framework that I remember when I was in college, I would turn on my computer, go get a cup of coffee, maybe have a donut, and then come back. And sometimes by then it would be fully booted up and I'd be ready to go do things. So I was willing to pay a lot for faster processing beyond the 386 chip or whatever that was in there that was revolutionary. Can you opine a bit on the future and sort of what's coming, what technologies grab you, what's out there on the hinterlands of futurism?
Well, I have a personal stake here because midway through my career, I said, I'll give it the end of Moore's Law plus 5 years. That seems like a good career. And yeah, if you look at the roadmap with just the transistor improvements to come, we've got in packaging, we've got a good solid 10 years of exploiting CMOS. I've actually never seen a more solid roadmap, despite us saying it's about to end, but it really will end. So we need something. We need another trick or several tricks beyond that. And yeah, it would be nice to avoid the donut break and just be patient. But the thing is, we're building a world around AI, and the AI workload is moving at a Moore's law of doubling every 4 months of performance on actual hardware. And therefore, you got this monster consuming every bit of our innovation in silicon and software. And how are we going to feed that monster? Because the world's depending on it. We do need the next trick. And that's why the CHIPS Act is I think, a game changer for us, because it's going, if it gets passed through Congress, it's going to really flood the zone with the type of innovation funding that is going to be required to completely rebuild the supply chain around an alternative to the CMOS that we know and love. And we all got our favorite candidates, but the consensus is they're just candidates. There is no consensus, and as long as there's no consensus on the next thing, it's hard to build a critical mass of research and scaling to get ready for that next thing. So I think the fear here is we should have invented it. We should now know what it is. In the next 10 years, we should be building the complement to CMOS. And yet what we're left with is, we spintronics devices, we've got negative capacitance devices, we've got carbon nanotubes, we've got perhaps a stretching of quantum effects, but none of them are high probability, and we're investing as such. So that's the world we are living right now.
Yeah, I completely agree with Dan there. What we're seeing from the partners that we work with is that they do have those long-term bets, but they don't consider them very high likelihood. Really advanced technologies far beyond what's possible now. And really the more near-term approach that they're taking is to stack chips on top of each other. So basically 3D build apps, whereas you would have one chip, consider like one story of a building. Now you're stacking multiple of them, creating a multiple story building to generate additional processing power. And people are coming up with the tools, with the materials, with the processes for doing that as kind of a placeholder. We see Samsung from our end doing that, as well as Intel. TSMC is really kind of helping enable the entire industry. People are also trying to compute in memory, which is an interesting application that's still in the very early stages. But there's no clear winner that anybody can see. We have some stopgaps. And kind of the way we're positioning ourselves on the Halo industry side is we see the need for the materials that enable some of these stopgaps, and we're kind of trying to put ourselves right in that linchpin position to help enable that at the cost that's needed to adopt this at large scale.
I would just add what Andreas has said is, like, especially with packaging, I think there's it'll buy us some time. all you have to do is look at what has happened in memory and memory density, which has entirely been enabled by stacking. Okay, now stacking memory chips is a lot different than stacking logic chips, of course, but you know, they're up to what, 192 layers, and you know, I bought it. It was something ridiculous, like a 256 gigabyte memory card, right? It's like, what are you kidding me? Right? It was like, I think I paid like $46 for it. I remember buying a 3 gigabyte disk drive when I was at IBM in the 1980s for $100,000, right? And here's 256 gigabytes for $46. It's kind of crazy, you know. But I think there'll be innovations in packaging, as Dan has pointed out. There's, you know, got to be some new technologies. I think there's also going to be a lot of, well, we're already seeing a lot of innovation in architecture, right? Which is, on the one hand, very important and refreshing. On the other hand, is a serious threat to players like Intel, who have really relied on, you know, high volume general purpose designs. And as that demand gets fragmented, it makes their challenge harder, which is why it's important for them to get into the foundry business if they want to keep competitive on technology.
That's what.
It's all.
Yeah. No, go ahead.
It's all good, and as I said, that will postpone the inevitable. But the inevitable we've seen before in bipolar. We're seeing it in CMOS. You got to get the power in. You got to get the heat out. That's physics. And eventually you got to get away from charge-based transistors into something new phenomenon. And that gets us back into some real fundamental science challenges. And it is the place where the United States is uniquely advantaged if we get our act together and we, you know, apply some pre-competitive collaboration. It's a real advantage that we've got.
Wonderful. That was our next question. And it seems it's a good moment to start reinvesting into the manufacturing business, into new equipment. And we have seen also in the past, for example, TSMC receive generous grants from the government. So my next question is how a government can play a big role in revamping you know, manufacturing and the technology powerhouse.
So I'm going to take issue with how generous the grants TSMC has received, okay? Because I think they've received favorable tax treatment. You know, they've received help in location and stuff, but, you know, I think there's a perception that they get much more than they actually do themselves. I mean, TSMC has been investing, well, they're going to invest $100 billion over the next 3 years. Yeah. They've been investing, you know, 10 to 20 billion plus for the last couple of years, and they've been at it for 35 years, right? So, you know, if we think $52 billion is going to solve this problem, that's a good down payment.
Yeah, I think my perspective is it's important to keep a market share in manufacturing. Winning it would be really expensive and maybe fighting last year's battle. I think our best is, you know, being competitive, keeping the supply chain robust enough that there's workers and researchers engaged, but really looking around what's the next thing to go after and not just trying to, you know, relitigate what's happened. It's happened for some good reasons and maybe not some not good reasons, but yeah, just as Willie said, you would have to 10x the investment to go win at yesterday's game. So I don't think that's go for the innovation, go for the new thing. That's where we can truly win.
I'm with Dan on this. This is what the U.S. has always done best. It's like invest in the leading edge science, right? Do public-private partnerships, but really invest for the future, right? That's how we will attract companies to want to be in the U.S. and manufacture in the U.S. But really, on that leading edge. That's what we do better than anybody else.
Absolutely. And we have a lot of dry powder. We're working with the DOE right now, and we have $17 billion just kind of sitting in accounts for investment in advanced manufacturing in the US for various fields. So we're trying to get them to give some of that to us for our work, but it's there. We just need to, I think, distribute it efficiently at the government level.
Wonderful. It seems exciting time ahead for for technology and for US manufacturing. So yes, I think we are just on time. And thank you so much, guys, Willie, Andre, and Dan. It was a lovely conversation, super interesting and fascinating. And yes, thank you again. And see you in 2 weeks for the next webinar.
Yeah, thank you, everyone.
Thanks.